So we're going to do our work with polynomials. We have to do some adding, subtracting, multiplying, dividing. We basically do all of the math that we've learned with numbers. We then apply it to variables as well. So we have to learn how to practice that. Now, one of the ways that sort of is an introductory for how to work with this is using something called Algetiles. Okay? Now, connection, some of you did you use tiles for mathematics in middle school or elementary school where they used a big square for 100, a line for 10, and a little square for 1? Okay? You remember doing that? And the reason that this was, the big line was 10 is because its area, it was basically a rectangle that was the 1 length along there and 10 length along there. And the big one was 100 because it was 10 length along the one side, 10 length along the other. So the area of it would be 100. Well, the same thing happens with Algetiles. Yes. Once your notes are out, then yes. Okay? The same thing happens with Algetiles. They're very similar, except we still have the 1, so it's 1 by 1. The x has a length here of 1, but some unknown length x as its height. And so its area would be x times 1, and it has an area of x. And the x squared one would have this side as x and this side as x. So if you calculated its area, it would be x squared. So you can do similar math to what you did with your 100 square, 10 square, and 1 square. But now we're going to be doing it with algebra. Okay? Couple other things. When you shade them in, they're positive. When they're not shaded in, they're negative. And I think the textbook makes some green and some red, and some textbooks change the colors. So when you're looking at the textbook questions, you might look in your textbook. They might decide different on what's positive and negative. But for us, whenever we shade it in, that's going to show that something is positive. And whenever we leave it blank, that's going to show that something's negative. Yes? Exactly. You're just like, if you had these tiles in numbers, would you agree that you have 100 plus a 10 plus a 1? And so this could be 111. When we get to the ones that we're doing here, what do we have? We have 2 of the x tiles, so we would write that as 2x. And we have 4 1 tiles that are negative, so we would write this as 2x minus 4. And in the second one, what do we have? We have 3 x tiles that aren't shaded in, so that would be minus 3x. We have 6 tiles that are shaded in, so we would go plus 6. And so what we're going to find is the Algetiles can help us do the mathematics. Eventually, you'll probably not want to draw them out because they take up a lot of room. So they're good for understanding, but they're kind of annoying for showing your work. That's why mathematicians like just writing an x, something I don't know, and keeping it simple that way. For the third one, these ones are filled in. We have 2x squareds minus 3x's, and then plus 1. Okay, before we get to the next question, I've got a challenge for you. Okay? We'll call this one D. I'm going to write out the Algetiles I want you to draw. They're all going to be positive. I'm going to give you an x squared. I'm going to give you 5 x's. And I'm going to give you 6 ones. First of all, you're going to draw it out in Algetiles. And then the challenge is going to be, can you take those Algetiles and make a perfect rectangle by putting them together? If you're having a tough time drawing it, and you would actually like to try making it with the Algetiles, you can come pick some up. Can you make a perfect rectangle using them? Once you think you've got your rectangle, woo, careful, there's a binder there. You want to try them? If there's not enough of the x's in there, you can come back and pick up some more. Here, I'll give you a whole tray of them. Yeah, but doesn't it actually, if you build it, it won't actually work. Here, I'll take these ones off. Here you go. Here you go. Here you go. Here you go. You can use those ones there. Yeah. You can, it doesn't matter. Just think of them all as positive. Technically, in those ones, the blue was positive and the red was negative.
Yeah, they took 5, so
No, not quite 5. Look, it doesn't match up perfectly. That's because it's an X. X is a weird thing. It doesn't fit with anything. Yeah, I know. It's got a Ooh, we got a rectangle. We got someone who's made the rectangle. Um. Oh, so. Thank you. It worked. Very nice. Very nice.
I made a square, I think. Wait, no.
Let's see. Does it work out perfectly? Look at that. We got 2 people. We're making a square rectangle. Technically, a square is a special kind of rectangle. Yep. Not with these ones. I can give you one that does make a square. Would you like to? Would you like it?
I would like to make
Here's one. Here, you want an easy square one or a harder square one? Harder square one. Let's go. Ooh, how big can we make it here? Well, I'll start off with not too big. X squared plus 6x's plus 9. That'll make a square. How do I know that? Whew. Now, if you can make these into squares and you can make them into rectangles, technically, you are already succeeding at grade 10 pre-calculus. But in grade 10 pre-calculus, you have to break them up into rectangles all in your head without the blocks. How would you do that? All right. For those of you, let's just, before you're working too much on the second one, on the first one, did you see that if you took your x, shade it in, and put an x tile here and an x tile here, shade it in, and 3 x tiles this way, shade it in, then you could put your 6 little ones like that and make your rectangle perfectly. Okay? Ooh, yeah, the square one's connected to this one, right? Okay, but before we get to the square one, what we just created was a rectangle. Algetiles are about area. Remember, I told you that the x squared was because of that, because it's x times x. Just like your 100 tile in middle school was 10 times 10 made 100. Okay? If we think about areas, my question is how long is this side? And how long is this side? X plus 2. Does that make sense that this length is x and these lengths are both 1s? That would be an x plus 2. How long is this side? Well, the whole thing is an x squared, but the side length is an x. Because an x times an x would make an x squared. So this length would be x plus 3. And since length times width is area, and the whole thing is shown with your area, x squared plus 5x plus 6, you could say that this is equal to, and this is grade 10 math, x plus 2 times x plus 3. Okay? And in grade 10 math, they're going to say, hey, if you have this, what is it? What times what? And it's connected to math that you've already done before. For example, if I told you the area was 24, can you tell me possible dimensions? Yeah, if the area of a rectangle was 24 units squared, centimeters squared, what could be the sides? 12 and 2. Is that the only possibility? No. What else could it be? 8 times 3. Good. And then 4 and 6. Is that all of them? It could be decimals, right? But is that all the whole numbers? 24 and 1. Nice. That's always the easiest one's always the hardest one to find. Okay? So in algebra, we do the same thing and say, what times what is this? X plus 2 and x plus 3 make that. And then with the square one, you guys realized you could just add. And so this is equal to x plus 3 times x plus 3. And because those two are the same, how do we show repeated multiplication? What's another way that I could write 5 times 5 is 5 squared. So another way I could write x plus 3 times x plus 3 is x plus 3 squared. And because it's squared, it makes a square. Wow. These words that we use in math are actually because they have meaning that way. I can, and I have, yes. But most of the time.
Honestly, that's such a good way of learning to factor.
Well, and you realize why it works, right? Okay. The problem is in grade 10, when you get there, you've already got so used to the algebra without the Algetiles that you're not using them as much anymore. Okay?
But even just to see it that way,
Yeah, just like.
they understood it the whole way through. Like,
This is this length, area, and how it's all connected. Okay. So now these ones, now we have to take our word sentence, translate it to algebra, and then translate it from algebra into our Algetiles. 3 less than twice x. Less. What kind of math is that? Multiplying, adding, dividing, subtracting? Minus. So we want to take twice x, which is 2x, and 3 less, we would minus 3. Now, how would we draw that in Algetiles? We would have 2 x's, and it doesn't matter if you draw them vertically or have them lying on their side horizontally, or even if you want to draw them diagonally. And then the 3's, does it make sense? We wouldn't shade those ones in. Okay. Yeah. And then on these ones, I think the red ones are negative, and it's, or, so it's kind of, there's no like fundamental, all the Algetiles are the same kind of look. The opposite, we've had this word, we had that word on our first test. Opposite means, right? Put a negative in front of it. So this opposite of x is just negative x. How do we draw negative x? We just draw our x tile without shading it in. Sum. Adding, subtracting, multiplying, or dividing? Adding. So what are we are going to add something. What are we going to add? The opposite of x, that would be a negative x, and 2. So those are the things you're adding together. How would you show that in Algetiles? There's your opposite of x. Well, I should have changed this one because I already did less than in A. I should have said something like the difference between x squared and 4 to practice more language. But I just said it, so I guess it's a same difference.
Yeah, I don't know if you guys knew, but me and JR, we went to different schools together.
4 less than x squared. So here's x squared. 4 less would be subtracting. There's our x squared. There's our minus 4. So far, so good? Okay. And now we get to the mathematics. Okay? Simplifying like terms, combining like terms, doing mathematics with algebra. So you have 3x plus 2 minus 5x plus 7. First of all, when you look at the ones, like, does it make sense? Here's our 3x colored in, plus 2. And here's our minus 5x, not colored in, plus 7. Or would you rather have the clear ones, so the blues are positive and the reds are negative, then you're not flipping?
No, this.
Is it okay? Okay. Now, from the Algetiles that I have here, does it make sense that you have 9 ones in the end when we put them together? And what's going to happen is every time you have a solid one and its opposite, they would cancel out. So one of these will cancel out with one of those. One of these would cancel out with one of those. And one of these would cancel out with one of those. what are we left with? We're left with minus 2x's, because the ones that are left aren't colored in, plus 9. Now the question is, do you think you could see from here the plus 9 without having to draw 9 squares and shading them in? Yes. Okay? When we talked about like terms, I'm going to underline my 2 and 7 in green, because those terms are alike. One of the definitions we talked about is two things are like terms if they have the same variables with the same exponents, okay? And both the 2 and the 7, those are constants. 2 plus 7 is 9. Then in a different color, and if you don't have a different color, use a squiggle line, something different. Can you see that those ones that are underlined in squiggly purple, the ones that are underlined in squiggly purple are like terms? Could you do that without having to draw out the Algetiles? Because if you have 3 of something, and you subtract 5 of that something, 3 minus 5 would get you to negative 2. So you could think of temperature. It's plus 3 outside, plus 3 degrees. The something is degrees. You subtract 5 degrees, you'd get to minus 2 degrees. And so the Algetiles can help us see that it's minus 2x plus 9, because the positives and negatives would cancel each other out. But most of you eventually will just say, I can do the algebra by recognizing what's alike and what's different. Guys, make sure you're drawing these Algetiles down. Okay, good.
On his arm.
Honestly, yeah. Okay, so here is breaking it up with the like terms, showing that I put the like terms together. We saw that with the Algetiles. This is what it means to do it with algebra, and we call something in algebra simplified if there are no more like terms together. And the word simplified, I think, in mathematics is one of the most complicated words that there is, because you've already learned, like, simplify fractions. It has a special meaning for fractions. It's going to have a special meaning for algebra. When you get to logarithms in grade 12, it'll have a special meaning for logarithms. The word simplify has about 100 different special meanings in mathematics. And it's supposed to be simple. That's why I said it's one of the most complicated words that's out there. Simplify. 5x plus 2x plus 6x squared. So if we're doing this with Algetiles, we could draw it all out and figure it out. If we're doing it without Algetiles, we would have to say, are any of my terms alike? Is 5x alike with anything else? Yes. So I could underline the 5x and the 2x in the same color. Some people like to use highlighters. Highlighters work really well for highlighting the like terms. Can you see that I shouldn't underline the 6x squared, because like terms have to have the same variable and the same exponents? Hello. Now, if you have 5 of something and add 2 of something, how much of that something would you have? Right? You'd have 7. So you can think of this as any object if you'd like. You have 5 apples, you add 2 apples, what would you have? You would have 7 apples. You have 7 apples plus 6 bananas. if we call the x squareds bananas, because the x and the x squareds are different things. And so this would be simplified. And now the variables don't have to be x's. We could have any letters. If we wanted to draw this with Algetiles, your Algetile for A would be a different size rectangle. Your Algetile for AB would be a different size rectangle. Are these like terms? Yeah. Because technically multiplying doesn't matter the order, so I could write BA times AB. They are like terms. I'm going to underline them so I tell myself in a different color or highlight them. They are like terms. And then the mathematics, once you recognize something as like terms, your mathematics is as simple as adding and subtracting regular numbers. So if you had 5 and you minused 8, what would you get? 3. Now, whenever I see AB, the object I think of is babies, but it doesn't really work here. If you had 5 babies and you subtracted 8, it just is not a good image. So let's go. What would you be left with? Minus 3? Oh no. This is this is not good mathematics. All right. Maybe we should think of rabies instead, because getting rid of rabies might be a good thing.
Well, you don't know if you have 5 rabies, then you can't get rid of it. You can't get rid of 8.
Yeah. So, or maybe it's a currency. The ABs is a currency. You have $5. You owe 8, so you pay the 5, and what are you still owing? You're still owing $3 more or ABs. Yes. Oh yeah, or you think of yeah. Definitely. Okay. Why? Are any of these like terms? They are all like terms. Y plus Y plus Y plus 3 Ys. How many Ys would you have? I have 1 Y plus another Y plus another Y plus another 3 Ys. Count them. 6 of them. 1 Y plus 1 Y plus 1 Y plus another 3 Ys would give you 6 of them. No. Oh, I missed one. Nope, there we go. Our example number 5. We're on example number 5. Example number 5, and your note has 4x squared minus 3x cubes. Simplify. Yes. This is a confusing one because the answer to this is it is already simplified. They are, but you will be tempted. Do you see how I would, in this case, I would underline this one in one color, and this one I'd squiggle line in a different color. They are not the same. We cannot add them together as much as we'd like to. Okay? And your human nature is that you want to put things together. So sometimes our just natural abilities fight against us because the mathematics says It's already simplified. We can't combine it. But you'll be like, but I want to. 4 minus 3, I'm so good at math. 4 minus 3 is 1. I want to write 1 something. So you will be tempted to do that. Okay, and example 6. In example 6, we have minus 6m plus 4n's minus 5n's and plus 8m's. Do we have any like terms with the 6m? Yes, the 8m. Do we have any like terms with the 4n? Yes, the minus 5n. So when we put these together, let's do the green underlined ones first. What would you get if you had minus 6 of something and you added 8? You'd have positive 2m's. I can underline that in green so we can see that we put those together. Then, if you had 4n's and you minused 5n's, you'd be left with negative 1n. Are you okay if I just write that as negative n? Whenever you have 1 of something, you can write the 1 in front. It's not wrong, but you don't need to write it in front. And I'm going to underline that in the squiggly blue. This is simplified. If we can simplify things, we make our mathematics easier. That's the whole purpose of combining things and simplifying things. Here we go. Here's our next one. Simplify the following. Okay, I'd like you to try these ones on your own. I'm going to walk around. Once you've got a couple answers, we can check them. So that is the area of the square, and you have to find the side length. So if I told you the area of a square was 25, what would the sides be? Okay. I know. So how do you multiply fractions? Because if it was 25 and you got 5 times 5,